video is on trig common values. So when you would use these would be in a non-calculator paper and you're told to do trig, they'd give you angles like 30, 60 or 45 to work with. Now you can just sit there and like try and remember them if you've got photographic memory. I'm going to try and help you, one, be able to work them out, and two, think of ways to remember them, and then we're going to do one question just to show like how a non-calculator paper would use them. So if we can see, we've got these values here. We've got sine 30, 60, 45, cos 30, 60, 45, tan 30, 60, 45. So that's not too hard to remember. Now there are some patterns in here, like a half, root 3 over 2, root 3 over 2, they swap, and then these two are the same. This is a root 1 over root 3 and a 1, so they're all like jumbled about root 3 and 1s if you want to try and remember it that way. But just to show you how you can work them out if you can't just remember them, we're going to go through that. So what we're going to do is we're going to look at the angles 30, so we know we need a right angle for trig, and this one is going to be 60, and I've done that because we're looking at full 30 and 60, so that's just helpful. And this one is 2, root 3 and 1, which you can check using Pythag and trig and stuff like that. So you would draw that triangle out there, so it's easy if you just remember that triangle. Now let's say I just wanted to find out what sine 60 was. So I've got an exam question, and then I've suddenly got this, and I'm in a non-calculator paper and I don't know what it is. So I draw out this. So first of all, I'm looking for this angle. So if I think SOHCAHTOA, just like we did for trig, I need the opposite and the hypotenuse. So I want sine, so this is my formula triangle. I'm looking for sine, so I cover up the s. So sine x equals O over h. Okay, now sine, we want sine 60, so sine 60. So if I label up my triangle, opposite to that is the one opposite, so this is O, then the hypotenuse is the long line h. So I know that sine 60 is, if I copy that, the opposite over the hypotenuse, which is 2. And then if I check that here, that's the same answer as up there. So that's how I'd work out that one. Let's do another one. Let's say I'm in my exam paper and I get asked for cos 30 and it's not a calculator paper and I'm panicking. So I draw this triangle out, and then if we write out SOHCAHTOA, I want the cos one, so the formula triangle looks like this. That's a h. And I'm looking for the cos value, so I cover it up. So I know that cos of x, of the angle, is the adjacent divided by the hypotenuse. What's the x? So I'm looking for cos 30, so this is the angle I'm dealing with. So what is the hypotenuse we know is this long one, and the adjacent is the one next to it, not opposite it, so this one left. Okay, let's copy that all in. So on this triangle we've got cos 30 equals adjacent there over hypotenuse there. And let's just check, yes, that's the same value there, but we haven't remembered it, we've worked it out from a triangle. There's one more triangle, so we've tackled the 30s and the 60-degree angles, but obviously you just need to like shuffle which one you want. What about the 45? So if we draw a 45, so we know it has to be a right angle. These are the same length because this is right angle, that's 45 degrees, and that's root 2, again check through Pythag. So let's say I'm looking for tan 45. Now I know that's TOA, SOHCAHTOA, so I know that is TOA, there's my formula triangle. I'm looking for the angle, so I know that that is the opposite, so I cover it up over the adjacent. If I just label that, so let's say we've got this one, the opposite would be here, and the adjacent is the one, not the longest one, the one next to it. Again, if I took this one, the opposite would be that, and that would be the adjacent, but they're the same, so you know, pick either 45. That won't matter, the maths works, don't worry. So that is going to be 1 opposite over adjacent, which is 1, which equals 1. So tan 45 equals 1, which is, you know, confirmed there. We can try it for a different one if you want, just, you know, get good practice. What about cos 45? So in my SOHCAHTOA, I want this formula triangle. So I'm looking for the cos, so I cover it up, so I have the adjacent over the hypotenuse. Okay, let's just pick, we'll use this 45 degree now, won't make a difference. So we've got this angle, what's adjacent? So it's this one, because it's not the one opposite and it's not the longest line, and then this is the hypotenuse, longest line. Okay, got the values, let's substitute them in. The adjacent there is 1 and the hypotenuse √2. Let's check that, cos 45, 1 over √2. Boom. So yeah, if you don't want to just like recite them, that's how I'm just showing you how you can work them out. So don't panic in your non-calculator paper. Let's hope. What about these ones here? So these ones are useful if I draw out the graphs. So first of all, if I draw out my sine graph, so that's the sine wave. Sine of 0, so this is 0. We can see that that is 0. Sine of 90, so we know that's 180. That's 360. So 90 is halfway between 0 and 180. If we go up and read that off here, that there is, which I haven't actually labelled, good. I'll say it's between 1 and -1. So as we can hear, so sine 90 from the graph, if we read it off, is equal to 1. It's one of the highest points. Sine 0, read it off from the graph, is 0. We can move on and look at the cos graph. So the cos graph is what we call the cos bucket. Again, oscillates between 1 and -1. If we put some values on here, we know that's 0. We know this here is 180 degrees, and we know this here is 360 degrees. Okay, so if we look at cos of 0, so that's when it's 0 on the x-axis, that is 1. And it's also the cos of 90 from the graph, halfway between 180, so it's this halfway point here, and we can see that that is 0 from the y-axis. So that's how you can get those, just by picturing, doing a quick sketch of the graph if you can't remember them, or remember them if you want. And then the tan graph, can't really remember what a tan graph looks like. Something like this. And as you can see, whatever it is, we know that tan of 0 here is equal to 0. And why don't we write tan, so we've done tan of 90 for sine and cos, but tan of 90 is this here. So that would be 90 degrees. But as you can see, it doesn't actually have a value because this is called an asymptote and this never actually touches the line here. So there's no value, and that's why there's no tan 90. Okay, let's look at a question in which knowing these might be useful because you might just assume you always have a calculator. So, okay, so I've got this question here, find the area of the triangle. So, the area of a triangle, first of all, what's the formula? We know it's a right angle triangle, so we know it's half times base times height. Substitute the information we know, a half is still a half. Let's call this base and let's call this height, times base times height. Okay, now we need to work out h, so how do we work out h? Okay, so if I took this angle here, and I want to know this h here, that is also known as the opposite in this, so don't get confused with the hypotenuse. So I'm going to rename that O instead of h, just to avoid confusion. And then we also have this one here, which isn't the longest side, so it's the adjacent. So if we write out SOHCAHTOA, we've got the opposite and the adjacent, so we've got this one, the tan. So the formula triangle looks like this. What am I after? I'm after the opposite, so I cover up the O. So the opposite here equals T times A, so tan of the angle, 45, times the adjacent times 10. We know that tan, this is the key point, this is why we do this. So we now know, or we can work out that tan 45 is equal to 1. This O looks like a 0, so the opposite is equal to 10 centimetres. I'm not actually going to lie, we didn't actually need to do all that because it is, these two angles are the same, so it is this isosceles triangle, so those two lengths have to be the same. So if you saw that, then well done. But yeah, so for example, that we used tan 45, and I could put this on a non-calculator paper, and you would have to know what that is. You can either remember it or work it out. Okay, so I was asked for the area. I don't know why I just like rubbed that out. We need that. So we know area is half times base times height, and we know that is half. And now we've got this value and this value, thanks to our trig knowledge and our memory of this, or working it out. And now we have the area is 50 centimetres squared.